For this first problem to figure out whether it was a 90, a 180, a 90, or a 270, I would graph it. For this particular one, you were correct, it was a 90-degree rotation because the ordered pairs flipped and became opposites, but it's actually the clockwise rotation. So if we went to where -6, +9 was, it would be about here, approximately drawn, and then we went to +9, +6. Notice it went this direction and it only went 90 degrees, because if it went 180, it would be down here. You can also know it's 90 degrees from the origin. It would make a 90, that's a little off, but it would make a 90-degree angle. But it's a clockwise rotation because it's going from this is K and this is K prime. So this would be the correct answer. This is going the direction of a clock. All right, triangle JKL is transformed by performing a 90-degree clockwise rotation about the origin, and then a reflection over the y-axis, creating triangle J double prime, K double prime L. What transformation will map it back onto it? So it's a reflection over the x-axis, but it's a clockwise rotation around the origin. So because you're trying to take it back, so we reflected it back over the x-axis, and I see where you got counterclockwise, but he clockwise rotated it and then reflected it. So we would reflect it back and do a, not sure about this one. This one might be an error. I would have agreed with the counterclockwise because you're trying to go backwards to get it back together, but they say it's a counterclockwise rotation. All right, what is the value of 2/3 to the -4? So common misconception is that a negative exponent makes the answer negative. It does not. The rule is that you get the reciprocal of the number and it becomes positive. So this is really 3/2 to the +4th. So you have to flip it over, and then 3 to the 4th is going to be 81, and 2 to the 4th is going to be 16. So this was the correct answer. Okay, and then for scientific notation ones, you're going to get a Desmos calculator on the final. It'll be the same calculator you used last year in the Desmos curriculum. But for these ones, the true rule is to divide the numbers and then use the exponents rule, but then you have to make sure that it goes back. But because we have these handy dandy calculators, make it bigger to see, 34. It'll divide it for us, and it gives us 3 times 10 to the 17th. And I think what your error was is that you subtract the exponents when you're dividing them, but when the first 2 numbers, the constants in front of the power, are just regular numbers, so you would divide them normally. I think you subtracted them. You did 9.3 minus 3.1, which is a common error, which is why it was one of the answers. So this was